Let's learn about material balance in chemical engineering. In chemical engineering, what goes in must come out. Look at the saltwater filter to the left. 50 moles of NaCl go in, 45 plus 5 moles of NaCl go out. 50 moles of water go in, 50 moles go out. For a batch process is how much in total, so 5 moles per process. For a continuous process, it's how many per over a time period. So that would be, for example, 5 moles per second. Now, in this example, we can have 3 different formulas we can use called material balance. That is NaCl going in is equal to NaCl going out. Water going in is equal to water going out. Adding these formulas together will form the total, which is amount going in total is equal to amount going out in total. This works with both moles and mass, but does not work with volume. The reason is because volume changes with temperature and pressure. Mass stays constant. So let's look at molar fractions versus mass fractions. They follow the same pattern of how much of an item divided by the total amount, but one is measured with moles and the other one is measured with mass. Now if you look, NaCl has a much larger molar mass than water, which is why it has a larger mass fraction. Let's learn about independent versus dependent equations. For a dependent equation, one equation is just a multiple of another equation. For example, x plus y is equal to 2, and then 2x plus 2y is equal to 4. Notice that the second is just the equation of the first times 2. Another one is when one equation is added from another set of equations. For example, x plus y is equal to 2, x plus 2y is equal to 5, 2x plus 3y is equal to 7. Now notice how the third equation is just the first plus the second, which is x plus y plus 2y is equal to 5 plus 2. So for part C, it could be just part A and B combined. For example, x plus y is equal to 2, x plus 2y is equal to 5, 3x plus 5y is equal to 12. Now notice how the third is just I plus II times 2, which is x plus 2x plus y plus 4y is equal to 10 plus 2. If you cannot construct an equation from another using these methods, they are independent equations. Why do dependent and independent equations matter? So, for a quick demonstration, try and solve x and y using the two dependent equations. So, step 1, put x on its own in equation 1. Now plug it into the second equation, and when you solve it, it'll equal 0. So, dependent equations cannot be used together to solve variables. So, why does this matter in chemical engineering? If you are using a system of equations in material balance, you have two options. Use only the separate chemicals, which is water in, NaN, or pentane in. Or you can use the total mass and separate chemicals, but leave out one individual item. Total in, water, and then Na. Notice how in this, there is no pentane. Total mass only becomes dependent if you include all available chemical material balances. However, if you decide to use all 4 equations in this example, you can only use it to confirm if your answer is correct. The amount of formulas we can make from material balances is equal to the number of non-reactive chemicals present in the system. This video does not cover reactions. So, time for a practice problem. Solve A, B, C, D, E, and F. So, for S1, we know that it's 10 times 60%, which is 6 moles of water. Since there is only water in NaCl, and all parts of a fraction must equal 100%, NaCl is simply just 100% minus 60%, which is 40%. And 40% of 10 is 4 moles, so therefore A is 40%. Now, let's find the 3 formulas. We will use the individual chemicals. So that's water in, which is in stream 1 plus stream 2 is equal to stream 3 plus stream 5 for the water, which is 6 plus 20 is equal to D times 0.5 plus 20. Now, that should leave you with D is equal to 12. Now, for NaCl, you have NaCl in stream 1 plus stream 2 is equal to the NaCl in stream 4 plus stream 5. That would be 4 plus 10 is equal to F plus 10, which is F is equal to 4. For pentane, you would have the pentane in stream 2 is equal to the pentane in stream 3 plus stream 4 plus stream 5. And that would be C is equal to D times 0.5 plus 5 plus 15, which is 26. For practice, let's use the total to come to the same answer. So that would be stream 1 plus stream 2 is equal to stream 3 plus stream 4 plus stream 5. And that would be 10 plus B is equal to D plus E plus 35. B and E are just sums of all of its parts, so that would be 10 plus 20 plus 10 plus C is equal to 12 plus 5 plus 4 plus 45, which would mean we would have C is equal to 26, which is the same answer. Now, B is just the sum, which is 20 plus 10 plus C, which is equal to 20 plus 10 plus 26, which is 56, which is equal to B. And finally, E is equal to F plus 5, which is equal to 4 plus 5, which is equal to 9, which is equal to E. Please like and subscribe. You don't have to, but it helps the channel.